Okay, good morning, everybody. Today's November 2nd, 2020, and today we're going to talk about graphing linear inequalities. So remember on Friday we did kind of a regroup day, so hopefully that gave you some time to be able to turn in some missing assignments. If you have any questions about your grades or anything along those lines, please let me know. In the meantime, graphing linear inequalities. First, let's ask ourselves the following questions. How do you graph the equation y equals negative 2x plus 1? Well, first thing you're going to look at is what is the slope. Remember that the slope is your m value. So if this original equation is in the form of y equals mx plus b, slope-intercept, then our m here is going to be negative 2. Or, so it's easier to graph, negative 2 over 1. Okay, what's the y-intercept? Well, the y-intercept is always that b value that's added on or subtracted. This is positive 1. So this would be b equals 1. Okay, so we're going to go ahead and graph this, and we're going to say that it starts at 1, and then it goes down 2, right 1, down 2, right 1. Remember, I'll always have 3 points on your graph. Okay, draw some arrows. I should have waited, but that's okay. All right, so then the next question asks, what are the solutions to that equation? So if you're in class on Friday, we talked a little bit about this, but if we are looking for the solutions to both this equation, okay, and the graphical representation of that, the solutions are on this line, right? So they're on anywhere on the line. So not just the 3 points that we plotted, but any of them. Okay, so what we're going to talk about today is inequalities. So if you remember back, the inequality symbols are here, 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 and here, which are greater than, or equal to, or less than, or equal to. Okay, so make sure that you get those down and that you remember which one's which. Okay, remember the alligator mouth opens up to the bigger number. Okay, so now using decimals, let's look at the equation y is greater than 2x plus 1. So graph what it looks like to the right. Well, first of all, it looks very similar to this one up above, except for notice the inequality symbol. So I'll tell you now, we're going to go ahead and graph it the same way. We're going to start at 1 and then go down 2 over 1, down 2 over 1. Okay, so now let's go ahead and look at how this looks in decimals. Okay, so before it went from y equals negative 2x plus 1, like this with the red line, and now we want it to be y is greater than negative 2x plus 1. Okay, so you can see the difference. So if I turn off the blue and then turn it back on, the difference is the shaded region, right? So an inequality symbol, when you put it into an equation, it turns it into an inequality, obviously. An inequality is stating that there are multiple solutions, just like the first, only there are more solutions either above or below the line, right? So to check to see where the solutions are, let's plug a point into the equation. Now, remember how we talked about open and closed circles? With an inequality, it's the same way. If you look on this blue side and you look at the shaded region, you can see that this is a dotted line. So we're going to change our format here. Go like this, and an inequality is a dotted line if it's a less than or greater than symbol. Okay, so maybe write that down. So dotted if it's less than or greater than. I'm going to go ahead and change this back. There we go. Okay, and it is a solid line if it's greater than or equal to or less than or equal to. Okay, it says to check to see what the solutions are, let's plug a point into the equation. So what they're saying is, in order to see which side the solutions are at, so like in the graph here, they're on this side, right? So what we're going to do is we're going to just pick a point on either side. Most times we say pick the origin point, which is 0, 0. So let's do that, and we'll plug it into this equation and see what happens. So 0 for y and 0 for x. Okay, so this says 0 is greater than, negative 2 times 0 is just 0, plus 1, and 1. So is 0 greater than 1? It is not, so that is a false statement. which means since I plugged in this 0, 0 point, okay, and it was not true, then that means I'm going to shade the other side of the line, which is over here. And that's why you see in Desmos that I have to the right, the blue shaded region. Okay. Now, the last thing I'll say about that is that if it is a dotted line, you will not have solutions on that line. If it's a full line, you will have solutions, right? So, shade over there. All right, so it says, is 0, 0 a solution? We just checked it. No, it's not. How do we know where other solutions to this graph would be? Since it's false, they would be on the other side. Okay. All right, so a coordinate xy is a solution to a linear inequality if it creates a true statement when you substitute those values into the inequality. So basically what that's saying is that if this that we just tried had come out to be a true statement, then we would shade this side. Since it was a false statement, we shade the other side. Okay, what is one coordinate point that would make the inequality y is greater than 4x minus 3 true? Hint, use the origin test for a true solution. Use a boundary line to cross the origin. Okay, so if, let's just say that we use a graph or Desmos for this one. So we're going to graph it and say 4x minus 3. Okay, so same symbol, it's greater than. So what's one solution that would make this true? Well, all you have to do is look in the shaded region. And so as you can see, I'm going to pick the point -10, +10. Okay, that would be a point in the shaded region of that inequality. So that would make it a true statement. Okay, so let's try to graph some of the inequalities together here, just without Desmos. What will these lines look like? Okay, so y is less than 2. Okay, well, y is 2 right here. So that's got to be a line, and since there's no line underneath, this is a dotted line. So we're going to make this a dotted line. Okay. And so what numbers are less than 2? Well, we have 1 is less than 2. We have 1 is less than 2. We have 0 is less than 2, right? So these numbers are all less than 2. So that means, as we're plugging those in, this is our shaded region of the inequality. You should always shade for an inequality. Okay? So anywhere in that shaded region, actually even further down. I didn't realize it went down further. Okay, so what's the slope of this equation? Well, since it's a horizontal line, right, it goes straight across, that tells us that our slope is a 0 slope. Our y-intercept is where it crosses the axis, which is 0, 2. This is a dotted line. And what test point could we have used to see where we shade? You could use 0, 0, right? And so since there's no x, we would not plug in for x, but 0 is less than 2, which, like we just did up here, is a true statement, and 0 is right here in terms of y, so that's why we shaded the bottom. Okay, let's try the next one. X is greater than or equal to 5. Okay, so this is a full line where x is 5. Okay, what's the slope? Well, it's a vertical line, so this is undefined. What's the y-intercept? It doesn't have one. It never touches the y-axis. It's a solid line. Okay, so let's pick a point on either side. So it doesn't matter what point you pick. We just primarily use 0, 0 because it's the easiest one to plug in. So I'm going to use 0, 0, but you could have used 6, 0, 7, 0, 6, 3. You could use any of the points here or any of the points here, just not a point on the line. So I'm going to use 0, 0. Okay, so this says x is greater than or equal to -5. There's no y, so I'm just plugging in 0 for x. Is 0 bigger than -5? Yes. So that means, oh my goodness, I just realized I put this at +5 instead of -5. I wonder what was going on. But that's okay, test point still matters, okay, because we use 0, 0. So is 0 bigger than -5? It is. So since this is a true statement, we're going to shade this side. okay? So that's how you test and then shade where the solutions are. Okay, graph the following inequalities by hand or using Desmos. Copy them down here, including shading. Let's go ahead and do this just by hand. So y is less than 3x minus 3. So it starts at negative 3, and then the slope is a positive 3, so it goes up 3. 1, 2, 3 over 1. 1, 2, 3 over 1. Okay, it's an inequality symbol with no equal sign underneath, so that means that this is a dotted line. This new update by Notability to make dotted lines is huge for this unit. Okay, so this is, let's see, slope is 3 over 1. Y-intercept was negative 3. This is a dotted line, okay? And how do we shade it? All right, well, let's pick a coordinate point. So it looks like this one here, 0, 0, is off the line, so we'll use that again. Plug it in. 0 is less than 0 minus 3, so 0 is less than negative 3. That's a false statement. So that means it's going to be shaded on this side. Okay, so again, using your points to plug in. And if you're not sure, you can always type this equation into Desmos. Okay, got a positive 2 is our y-intercept. Our slope is 1/2, up 1 over 2. Up 1 over 2, up 1 over 2. Okay, this one does have a line underneath, so this is a full line. Okay, so we graph it that way. Draw our arrows. Okay, and then we're going to pick a test point. Again, 0, 0 is off the line, so that's the easiest one, so we're just going to use that. 0 is greater than or equal to 1/2 times 0 plus 2. Plugging in 0, 0 for x and y. So 0 is greater than or equal to 0 plus 2, which means 0 is greater than or equal to 2. This is also a false statement. It's not true, so we're not going to plug 0, 0, but instead we're going to graph or shade on the opposite side because it was false. Okay, that makes sense. All right. Oh, I forgot to say this is solid. So, what you have for homework tonight is an exit ticket. I want you to go ahead and graph them. Don't forget to list your slope, y-intercepts. Listen, you're going to be able to use Desmos on this, and I completely understand that, and I encourage it. Okay, but really try to graph these by hand first. Okay, get some practice with slope-intercept form. Tomorrow we'll probably, well, Wednesday we'll cover some standard form and how that looks with linear inequalities as well. So, have a great rest of your day, and I will see you guys soon.